Algebra 1 students, welcome to your 6.2 notes. Today we're going to be looking at a second way to solve systems. We started with graphing. Today we're going to look at substitution. It's a different way. It's a really good way, in my opinion, to solve systems. So we'll start with a fairly basic one. It says the system is y equals 4 and 2x plus y equals 12. You can read the instructions up here, but essentially step 1 is done for us. We've solved for one of the variables already. So I'm going to take this information and plug it in right there for y. So I'm going to rewrite the second equation, but instead of writing y, I'm going to write 4. When we subtract 4 from each side, we'd get 2x equal to 8. Then we could divide and we'd get x equals 4. Now this one is a pretty quick one because y was essentially given to us and we just found x that fast, so our solution would be 4, 4. Now remember, if we were solving this by graphing, which we definitely could, we would find that the two graphs intersect at that point. All right, so let's take a look at some others. You can see number 1 here. It says y equals 3x minus 7 and x equals 5. Now this is a lot like that first example where one of the variables is already solved for us. So we're going to go ahead and just plug that directly in. I'm going to rewrite the first equation. Instead of 3x minus 7, it's going to be 3 times 5 minus 7, which would give us, of course, 15 minus 7, or 8. And again, we quickly have an answer to our system. Some of them are not quite as simple, although I would say this number 2 is a bit of an in-between step. This is good. We've already solved for y. It's y equals 3x. We're going to plug that in. 2x minus 3. And now note that we have a y here, but I want to substitute it. Instead of writing y, I'm going to write 3x is equal to 28. 3 times 3x would of course give us minus 9x. And I don't know why I wrote 2x there. 28 was of course the number. And negative 7x is equal to 28. When you just simply take 2x minus 9x, that gives you negative 7. And divide by negative 7, you get x equals negative 4. Now the thing about these, the additional step on this, is once I find that first value, I have to go plug it back in to our equation. So I'm plugging it in right here for x. So y then would be negative 12, and our solution would be the ordered pair, negative 4, negative 12. And again, on any of these problems, if you find a solution and you want to check it, you always have the option of graphing to confirm your answers. Let's go ahead and look at number 3 here. Y equals 4/3 x minus 6. Notice that we have a y value here that's defined for us as 4/3 x minus 6, and then I'm going to solve, or excuse me, I'm going to plug that in for the y that's down here. So my second equation, I'm going to rewrite it. It's going to be negative 5x plus 3. Now instead of writing y, I'm going to write what y was equal to. Again, that equal to sign means the left and right side of that equation are exactly the same. So negative 5x plus 3 times 4/3 x minus 6 equals 6. So all I did was trade a y for 4/3 x minus 6. Now we need to use the distributive property here. Remember, you're multiplying that 3 into 2 separate places. So our next step would look like this: negative 5x plus 4x. 3 times negative 6 gives me minus 18 equals 6. I'm going to go ahead and add 18 to both sides. I'm going to do two things at once here. I'm going to combine my like terms as well. So I'll have negative x, that's negative 5x plus 4x, equals 24. So x then would be negative 24. Now again, I have to kind of go back to the beginning, give myself a little space here. I'm going to use the first equation. Some of you may prefer the second. That would be totally fine. And I'm going to plug in 24 for x. So y then would be, well, 1/3 of 24 is 8. 4/3 then would be negative 32 minus 6, and y then is negative 38, and there is my solution, negative 24, negative 38. On number 4, what I noticed right away is that the second equation is going to be fairly simple to solve for either x or y, and in this case it would be x. If I simply divide both sides by 3, I would have x equals 2y minus 3. Now I want you to work through the rest of this problem on your own and compare your answer to mine. So right now, hit pause. Alright, welcome back. You can see my work on number 4 by substituting in for x and simplifying after I distributed, combined like terms, and added 15, and then finally one step of division. I was able to find that y was equal to 4. And then I took this x equals 2y minus 3 and plugged in 4 to find my x value, which was 5. All right, so there are other ways to approach that one, but I think that's a pretty good way right there. All right, let's keep on going on. Sometimes we run into weird stuff. Okay, so this is about life, but also it's about solving systems of equations. So let's take a look at this and see. Now this looks like a pretty straightforward setup. Y equals 7x. We can plug it in for y. 7x minus 7x equals 18. Well, 7x minus 7x is 0. And the question is, when does 0 equal 18? And the answer, of course, is never. So that is just simply no solution. All right, let's take a look at the next one. Again, we have a y equals, and right here we see a y. So I'm going to plug in that value. So 4x minus 2y, but instead of y, I'm going to do 2x plus 3. Because I know y and 2x plus 3 are the exact same thing. That's what the first equation tells me. It's equal to negative 6. So then I'll have 4x minus 4x. Again, I'm using the distributive property. Negative 2 times 3 gives me minus 6 equals negative 6. Well, 4x minus 4x is 0. So when is negative 6 equal to negative 6? Well, that's always true. So what we have here are an infinite number of solutions. If you think about these two graphically, like we did with our first method for solving, number 5 would be parallel lines, same slope, but they don't intersect. Number 6 is actually two lines directly on top of each other. We can call it like concurrent lines, or essentially any point along that line would be a solution, so there are an infinite number of them. All right, let's take a look at these next two. We have just a little more work on the setup side before we can jump right into solving them. But when I look at number 7, I see that the second equation here is fairly straightforward. If I add y to each side, I'm going to have x equals y plus 4. Then I can take that new value for x and substitute it in right here on the first equation. So I'll have 2 times y plus 4 minus 5y equals 19. So again, I rewrote the first equation, but instead of x, I found what x was equivalent to, which is y plus 4. So I'm going to go ahead and then distribute the 2y plus 8 minus 5y equals 19. I'll subtract 8 from each side, so negative 3y, that's 2y minus 5y. 19 minus 8 would give me 11. So y then is negative 11 thirds. Now that is obviously not the prettiest answer we could come up with, but it works. And what I would do from there is plug it in. I'll probably use the second equation, x minus negative 11 thirds equals 4. So essentially what I need to do here, this is x plus 11 thirds equals 4. So I need to subtract 11 thirds from each side. This is 12 thirds, so I'll get x equal to 1 third, and that's my ordered pair. All right, why don't you guys try number 8 on your own? So right now, hit pause on the video, do number 8. All right, welcome back, folks. You can see my work on number 8, what I've done here is solve the second equation for y by dividing by 3, plugged it in. Now we came up with a funny situation here. 20 equals 20. That told me we had infinite solutions. Another way to say this would be these two lines that you saw here are actually the exact same line. If you graphed them on the same graph, you would see that they exactly overlap. So we're really just talking about one line here. So any place on that line, there'd be a lot of points that would actually satisfy the system. All right, let's take a look at the next one. A little reading here. 15 friends decide to attend a Sporting KC game. Good choice. It's $30 to sit in the members club, and the South Stand tickets cost $35. They couldn't all sit together. I'm paraphrasing here. I know you guys can read it, but it cost a total of $480 for the tickets. They just had to split up. All right, so to find variables. Well, in this particular problem, we got two variables. One is the number of tickets in the members club. So I'm going to abbreviate that and say the MC tickets. And then Y could represent the number of tickets in the South stands. So I'll just do number of SS tickets. All right. Now our system, well, we got two things we know. One is there are 15 total people, so they better have about 15 tickets. So I'm going to do X plus Y is equal to 15. That's my first equation. My second equation has to do with the amount of money that they spent. Each person that was in the members club spent $30, and in the South stands they spent $35, and the grand total was $480 for the 15 of them to go to the game. So our system looks like that. Now, of course, we still have to solve this system. So what I'm going to do, and there are multiple ways to do it, but this clearly says use substitution. So I'm going to go ahead and solve for x right here and say x is equal to 15 minus y. Now we could have solved for y. That would be totally fine. But I'm going to use that and plug it in right there for x. So we're going to have 30. And then instead of x, we have 15 minus y. We still have plus 35y. It's equal to 480. I'm going to use the distributive property here. So 450 minus 30y plus 35y is equal to 480. Now from here, I can combine my like terms and subtract 450 from each side, and with some quick division we can see y was equal to 6. If I go back to my original, x plus y is equal to 15. Oops, jumped ahead in my brain there and wrote the wrong number. Then I would know x is 9. So what does this mean? Well, it means 9 purchased, and we set up above the x represented members club tickets, and the other 6 sat in the South stand. So all 15 got to go, but they had to split the group. All right. So let's take a look at our last question here, number 10. It's dealing with a little geometry. It's telling us the measure of an acute angle of a right triangle is 36 degrees more than twice. That's an important statement right there. Twice as big is the measure of the other acute angle. We're going to define variables, write the system, and solve to find the measure of the two acute angles. Essentially, we have something like this. We have a right triangle. I'm just going to sketch it just to kind of remind myself what we're looking at. I'm going to call this angle x. It's the smaller angle, and y is the larger one. So x, we'll say, is the smaller angle. That's the symbol we can use for angle. And y is the larger acute angle. Again, I'm just going to kind of abbreviate and say the large angle, even though 90 is actually the largest of the three. All right, so what we know, I'm going to use the clue that's down here. The three angles sum to 180. So I'm going to do this, x plus y plus this right angle, which is 90 degrees, has to equal 180. Okay, now maybe you would want to subtract 90 from each and maybe just write the system like x plus y equals 90. Write the equation that way. All right, now we have another equation. It says the measure of one acute angle is 36 degrees more than twice as big. Well, that means that the larger angle, which we said was y, is 36 degrees more than twice as big. So if you do 36 plus 2x or 2x plus 36, you would have your other equation. I know that's a little tricky maybe for some of you to come up with that equation, but if you take a look at this, it kind of makes sense, doesn't it? The big angle is 36 degrees more than twice the small angle, and those two angles have to add up to 90 since the three add up to 180. All right, so we're going to do some quick substitution here. I see I have a y here and a y here, and that's where I'm going to approach it. X plus, so instead of y, I'm going to do 36 plus 2x, that's my substitution for y, equals 90. Let's combine the x's, so I have x plus 2x. Really, these parentheses I've written here aren't going to make any difference, but I wrote them because sometimes they do when we substitute. In this case, we don't have anything to distribute, so it's no big deal. When you subtract 36 from each side of the equation, it gets rid of it here, and here you get 54. And then we can divide. We know that x is exactly 18. Now you can choose which of the two equations that we use. I'm going to use the first one, although I think it's kind of a toss-up. Either of these would be just fine, but 18 plus y equals 90. When I subtract 18, I get y equal to 72. So my two angles are 18 degrees and 72 degrees. Now, sometimes I think it makes sense to go back to the original and answer the question, does that make sense? And I see that the larger angle is 36 degrees more than twice as big. So I look at this and say, okay, well 18 times 2 is 36. If I add 36 more, it's exactly 72. We've got it. We also know that 18 and 72 sum to 90, so that satisfies that equation. We've got our angles. We've got this figured out. We've used substitution. You guys have a spectacular day.